Okay, good afternoon. My name's Trevor Graham, and I'm a member of the team that has brought you the Manufacturing Predictive Maintenance using 5G Catalyst project. Now, this is an ecosystem project. It's championed by TWI, with Verizon, Inquiring Minds, and Huawei participating. Now, today we're going to have a panel discussion in which we can get into some of the details of the Catalyst and talk it through. But first of all, I'm going to take just a few minutes to outline the project very, very briefly. So, manufacturing is a hugely important sector for the global economy. It delivers about $12 trillion to the global GDP, and it represents over 70% of international trade, so it's a very, very important sector. But manufacturing is also a highly innovative industry. It spends billions of dollars every year in R&D, and it adopts new technology in a drive to increase productivity and efficiency at a great rate. And one area that shows great promise is that of using the data that we can collect from connected machines to reduce unplanned outages, predicting when maintenance might be required using machine learning algorithms. And studies suggest that the predictive maintenance market alone is worth about $140 billion globally. And connectivity and cloud technologies are right at the heart of those use cases. So this is a use case that's well worth exploring for the telecoms industry. And it's only one of many manufacturing use cases that can drive telecoms revenue. So in this project, we set out to explore how can 5G technology enable predictive maintenance and predictive control use cases, and understand what characteristics we need to build as an industry into the 5G networks that we design and we implement in order to maximize utility to the manufacturing sector. And as well as looking at the technology, we also investigated the commercial business models required to bring these use cases to market effectively. So these are use cases that are delivering specific value inside the vertical. They're more than just connectivity. And how the telecoms industry can best serve that global manufacturing industry through collaboration and federation. So on this slide, in this project, the use case that was proposed by our champion TWI involves a cutting-edge manufacturing process called selective laser melting. And if you come down to the booth on level 2, we can show you this in operation. We're booth B1, and it's really cool. This is effectively 3D printing in titanium, which is quite amazing. And the build process is, as you'd expect for such a cutting-edge process, is time-consuming and expensive. So the losses when builds go wrong can be quite large, both in terms of lost time and lost materials that are expensive. So we've got an economic model that suggests a typical factory could avoid around $5 million in direct costs alone, as well as improving overall productivity significantly if we can use predictive algorithms to improve the build process and improve the control of that build in real time. So this diagram shows the test system that we derived for this catalyst. The laser machine is augmented with a high-definition infrared video camera, and that transmits a continuous stream of uncompressed high-def video over a 5G interface to predictive maintenance algorithms running in edge cloud, effectively a near-at-hand cloud node running inside the network itself. And the algorithm learns continuously from all the data that it collects from this machine and from many machines inside of a factory, and potentially many machines across a regional area, to improve its algorithm and allow it to better intervene in the build process if it's about to fail, and improve the overall output. So how it does that is by effectively sending control signals back over the 5G network and into the system to effectively influence the power of the laser and make the build work. Now, the round trip of capturing the video, processing it, making a decision, and then sending the control signals back to the plant and to the machine, that has to take place in a few tens of milliseconds. So that's very challenging. So you can see that this is a fantastic use case to explore the characteristics of 5G networks, because it's got very high bandwidth for uncompressed data. The very act of compressing and uncompressing the data adds delay. It requires very low latency. You've got a few tens of milliseconds to make this happen. And the flexibility that virtualization and edge compute can bring are critical to the use case as well. So if you come down to the booth, we can show you this process running, and we can talk about the results of the experiments. So then, in terms of how such a service could be brought to market commercially, we built this model of a notional product offering. And it's a complex product. It's a lot more complex and a lot more moving parts than a classic telco connectivity service. If you think about it, we've got the deployment of connected sensors, we've got 5G connectivity, small cells inside the factory, because a factory is a really challenging environment for wireless comms, as you can imagine. There's lots of interference, there's lots of big bits of moving metal, and it's likely that a small cell infrastructure will be required. And then inside the network, you've got a 5G network slice with very specific characteristics, and you've got a MEC node that can run the predictive maintenance algorithms close to where the intervention is required. So there's a lot of moving parts, and actually our proposition here is that really the only way to bring this to market effectively is through an ecosystem of partners. Now, you heard downstairs this morning in the keynotes about ecosystem, and that's really the best way we believe, to bring this kind of service to market, because we need people with deep expertise inside the manufacturing vertical, and we've got that in the panel and in the group of people who are put together to deliver this catalyst. So that collaboration, we can talk about it some more at the booth if you come down, but we've got some thoughts about how such an ecosystem could be enabled efficiently on a global scale, with many different players involved in the ecosystem collaborating in effectively a federated model. So I've talked long enough. I'm going to hand over now to the panel, and we're going to talk through some questions that'll help us explore aspects of the solution as we go through in a bit more detail. And hopefully we'll have some time at the end for some questions from the audience as well. Thank you. Could you unlock for me? Okay, so Darren, as lead champion for this catalyst, I'm going to start with some questions for you. So in Industry 4.0, what role do you think 5G technology specifically can play?
Okay, thank you very much, Trevor. Afternoon, everyone. My name's Darren Williams. I'm the Welding Systems Manager at TWI. So at TWI, for Welding Institute, we focus on welding and joining materials. We have over a dozen different techniques and technologies that we use to join materials together, and a lot of these have a midriff of key process variables. For example, one of our arc welding processes has 50 to 60 different key process variables, and with that, we only currently monitor 2 or 3 of those variables. But Industry 4 allows us to collect all that data, analyze that data, and utilize that data to provide key machine insights to enable us to get better right first time, better quality, and better productivity. With the 5G now, this allows us to utilize faster action on those key process variables, so we can control in real time, unlocking these lower latencies facility from 5G to make us improve the monitoring and control of our systems. So yeah, it's key. Thank you.
Yeah, absolutely. Thanks, Darren. So you talked about, obviously, predictive maintenance, predictive control there. I mean, have you any views on why predictive maintenance is so important to the manufacturing industry?
Yeah, so previously we've used reactive maintenance models or schedules where when an issue comes about, we're reacting to it, which therefore there's maybe processes are backed up, processes are stopped. So machine time's lost, productivity's lost, and then we're assigning resource on the fly to try and resolve those issues. Looking at predictive maintenance, we can resolve those issues before they actually occur. Therefore, minimizing downtime, minimizing products lost in the supply chain, and getting the productivity up as much as we can. So it's very, very key to us.
Okay, brilliant. Thanks very much, Darren. So Matt, moving along to you, you had responsibility for the 5G connectivity parts of this project. So what are some of the challenges in connecting together all this manufacturing equipment?
No, thank you, Trevor. I think some of the biggest challenges that we see is, like you said, factories have a lot of interference. So with Wi-Fi and other lower frequency type of wireless technologies, it's tough to get that reliable connection. And then the alternative for low latency, high bandwidth is a fiber connection, which obviously is difficult in a factory setting. So 5G really allows us to have the low latency, high bandwidth, high number of devices. If you have things like forklifts or things like that that are mobile in the factory, it can support those mobility requirements. Really all to come together in a highly reliable fashion. So.
Okay, brilliant. And could you share your thoughts on some of the aspects of edge cloud, what role edge cloud might play in this kind of use case?
No, absolutely. So I think up into today, you see a lot of compute on devices themselves, whether they're in the video camera or in an autonomous vehicle or anything else like that, which causes those devices to be very expensive because they have the software as well as the device themselves. Alternatively, then you have enterprises that have to deploy an edge infrastructure within the factory to handle a lot of these workloads, which is cumbersome because a lot of the factories are in remote locations. They don't have a lot of skilled staff there to handle the equipment. So really standing up that equipment, maintaining it, having that IT staff local to the factory can be difficult. So what Edge Cloud allows us to do is if you're leveraging the 5G network and you can have this the compute located right where that signal ends on the radio access network, you can have the computer vision software in this instance running in a very low latency, high performance way without having to have very expensive cameras located at the device or without having to maintain a local IT staff within the facility.
Okay. And Matt, given that most of our audience is probably from the telco industry today, have you any thoughts about other opportunities inside this sector of manufacturing for telco?
Sure. So I mean, I think in addition to the traditional kind of wireless stuff, I think there's also a big opportunity for a managed service type of solution here. You know, working with the manufacturers to solve their problems. Also, like I said before, to help relieve the manufacturers of the burden for having their local IT staff. If we either want to use our mobility public 5G network, or we can either, in a lot of larger factory settings, install a private 5G network within the facility and have an edge compute stack there. We can have that be a managed offering. We can also allow them to have a seamless handoff from their mobile devices to their MPLS SD-WAN devices. So be able to do that dynamic, seamless mapping from their wireless edge through to their MPLS network and their back-end network. And then layer on the platform capabilities and the professional services as we're doing that installation and everything else for the industry.
Okay, great. Thanks, Matt. So Nick, you brought the expertise in machine learning and predictive analytics to this project. So what do you see as the key barriers and the challenges to scaling up and adopting globally this kind of predictive algorithm in the industry?
So from our experience, the analytics bit is actually the easy bit. We've applied very similar analytical techniques, not just to other industrial maintenance applications, but a very, very broad spectrum. So some of the core algorithms are very, very versatile. The challenges just comes down to the plumbing, and there are three main issues that come up again and again and again. The first one is just legacy information and legacy systems. A lot of industrial manufacturing already have kit in situ. It's generating data. It's perhaps not wireless, but there's a problem of extracting that from the existing machinery. But there's also a lot of enterprise data that sits sort of around that's extremely valuable. If you want to sort of like contextualize the maintenance problem, you've got to know historically how frequently are people doing maintenance, which can mean pulling in sort of inspection records, so very classically non-digital stuff. So enterprise legacy integration is the first challenge. The second one is security. And a lot of industrial manufacturing companies have security concerns for very legitimate reasons. This is a very, very expensive kit. They don't want it to get hacked. But just ignoring that issue, downtime is incredibly expensive, whatever the cause of that might be. So that you need to be able to insulate their security concerns in a watertight way. And then the final one is just pure volume of data. I mean, coming from sort of like a lot of the classic IoT we stuff and doing smart cities, etc., on an NB IoT network, the frequency is very, very low. You're dealing with little dribs and drabs coming in. These applications, the other end of the spectrum, you know, it's a fire hose of data. Some of the installations we're talking about can generate hundreds of terabytes an hour. So you've got two problems there. One, getting the bits from A to B, and that's where the 5G comes in. But then secondly, you need to know you've got the analytical wherewithal to be able to process that in real time.
Brilliant. Thanks, Nick. So we've got a couple of minutes left, and before I hand over to the audience to see if we've got any questions, there were a couple of questions that were posed before we came down here. So Joanne O'Brien at TM Forum asked us, could we outline the commercial learnings and observations from the project? So I'll have a go at answering that one. And really, what it comes down to is, as I said during my pre-roll in the intro, these kinds of products these offerings are really quite complex. They involve a lot more moving parts than a classic pure raw connectivity offering. But at the same time, what we hear from the manufacturers that we go out and talk to is that for the telco industry to offer just undifferentiated raw connectivity without any vertical value add is really not a very attractive solution to them, because it leaves the manufacturer to have to either themselves or with the help of a systems integrator to stitch together everything that you saw in the end-to-end product, including really, really deep expertise in things that Nick's been talking about, like the predictive maintenance and machine learning algorithms. And that's really challenging for any one telco to have that level of expertise across such a broad spectrum of capabilities. And so really, when you get to that point, you think that really the right way to do this is through an ecosystem. It's to bring partners together, to collaborate, to deliver that service as a piece of joined up offering to market. And once you've made that leap into deciding that you're going to enable an ecosystem, an analysis of other industries makes it clear that there's one really good standout way in which we can deliver and manage an ecosystem of very diverse partners, and that's the platform model. And there's a lot of academic research that's gone into what a platform is and how it works. But effectively, what we're talking about here is using technology and a technical platform that allows services to be brought to the market through effectively a single pane of glass, but at the back end having multiple partners, third-party providers and consumers transacting through that platform and exchanging value and revenue through that platform. And that seems to us to be the best way to bring such a diverse ecosystem to market. And then that naturally brings us to a question that Joanne posed as well about the fact that manufacturing is a global business. How do we do a common solution for a global provider, for a global manufacturer across telco, which is naturally quite a diverse and fragmented business. Now, telcos have traditionally been really good at things like roaming, things like using standards to deliver global services, but any one telco tends to operate inside one region at best. So it seems that using a platform and having multiple telcos from multiple geographies come together inside that platform, it federated, as it were, a bit like the way that the airline alliances federate together multiple airlines to deliver a global stitched together service. Seems like the best way to pull together a service and deliver it globally to a global audience. So look, that's all the questions that were submitted ahead of time. So we've got probably about 2 or 3 minutes left. If anyone in the audience has a question that they want to pose to anyone in the panel. Yeah, go ahead, Ben.
So Nick, you talked about the amount of data which machines have. Some of it requires the latency of 5G, and obviously some of it doesn't. I just wonder how this catalyst might be a question. How do you reconcile the need for high low latency of data and the more kind of batched type of data? How do you reconcile those two requirements?
Well, I can tell you how we do it. So, I mean, our back-end processing system, our analytical system, is entirely distributed. So there's one analytical function with the high latency requirement that will sit on the edge. So that's where it goes. Other stuff might be taking in, terabytes of information from our batch enterprise system. That could sit anywhere. So you've got it's like a triangle. You've got a high latency line to the edge. You've got another mechanism which could be like offline batching to another data store. But then the way that our analytical architecture is designed, you can then conjoin those data sets separately. So
how would, thanks for that answer. The other part of the question is how would the 5G connection differentiate between, what can you do with 5G that for certain applications you wouldn't need anything more than 3G? Sure.
They didn't want me to talk anymore, but no, I think the way we approach it is really we see 5G as an augmentation to 4G and other type services. We don't see it as a replacement. I think that's why LTE was given the name long-term evolution. So in all of our deployments, whether they be in our mobility network or even in a private enterprise deployment, it's always anchored with our 4G radios. So if you have Cat-M devices or narrowband devices, those are naturally going to connect over the Cat-M or narrowband network, whereas the 5G high bandwidth stuff will go that way. I also think, built into our platform, into our edge compute stack, we do have that data orchestration and routing layer, because that's what we do. So we can, even for the 5G devices, everything will have kind of a service profile against it. The devices, when we authenticate the device and have that identity, we'll be able to say this is a service profile against it. And if it's a mission critical app, route it one way. If it's a high bandwidth, low latency app, route it that way. It's all part of the network slicing function and things like that. So it's part of our data orchestration software. where we would look, within the network slices or even the service profile associated with that device. And then additionally, you have the Cat-M narrowband devices that are going to connect over 4G versus 5G, if that helps.
Okay, I think we're probably just about out of time. I would say we're down in booth B1. All the guys will be there over the rest of the week. If you've got more questions, Ben, if you wanted to follow up, or if anybody else has any questions, come down and see us. We'll be happy to show you the demo. It's really cool. We've got some titanium parts that have been 3D printed. I can't get my head around it. But come ahead and we'll talk you through it all. Thanks very much.